Hi, everyone. Welcome. As we have many attendees with us, we kindly ask you to place yourself on mute. We will have a Q&A session at the end, so if you have any questions during the presentation, please type these into the chat box you should see at the bottom or side of your screen. Please also note that we will have a post-event survey, and we would really appreciate you taking the time to provide us feedback on the content of this webinar. This webinar will be recorded and made available at a later date. My name is Stephanie Franco, and I would like to introduce you to today's speaker, Akbar Anwari, who is Marketing Manager for BrandTech. With that being said, I am going to turn the presentation over to Akbar.
Hello, everyone. Thank you, Stephanie. Thank you for taking the time to join us today. Today's webinar, we will be discussing how to choose a Bottletop dispenser. One second. There we go. Welcome to our presentation. As a general overview of the topics we will be covering today, we will discuss what is a Bottletop dispenser, how it works, general design features that make one design suitable for certain liquids and not others, safety and convenience features that may be important for different applications, and some economical designs that may be suitable for less demanding applications. As an introduction, we should be clear on what we're talking about here. A Bottletop dispenser is a specialized version of a piston pump used to measure preset amounts of liquid from a bulk container. It is a faster, easier, safer, and frequently more convenient or more accurate way of measuring liquids than a graduated cylinder. Though a Bottletop dispenser may seem simple, they're quite accurate. ISO specification is less than or equal to 0.6% of the nominal volume for most sizes. The basic components of a Bottletop dispenser are simple. There's a piston and cylinder that define a nominal or maximum volume for the dispenser when raised to its maximum height. There is a filling tube that reaches below the surface of the liquid to be dispensed and allows liquid to flow into the cylinder when the piston is raised. The discharge tube to dispense the liquid, plus two normally closed one-way valves are present at the inlet and outlet of the cylinder to direct the flow of liquid.
Thanks, Akbar. I think at this point, we are going to open up our first poll question. You should see the polling box at the side of your screen. If needed, you can drag this box to make it larger so that you can read all of the text. Our first question to the group is, do you have Bottletop dispensers in your lab? The answers can be A, yes, B, no, or C, no, but I think they could be pretty useful. So I'm going to go ahead and give everybody a few more seconds to select your answer before I close the poll. A few more seconds, waiting for a few more responses. All right, so now I'm going to go ahead and close the poll. And let's see what we get. Great, it looks like a lot of you out there already have Bottletop dispensers in your lab. So with that, we'll turn it back to you, Akbar.
Thanks, Stephanie. Let's see here, get back to the screen, and Bottletop dispensers break down into two fundamentally different technologies. A wiping seal design, where the piston seal has direct contact with the cylinder, and a floating piston design, where the dispensed liquid creates a seal between the piston and cylinder. The first design we'll look at is the wiping seal dispenser. In the wiping seal dispenser, the bottom of the piston has a flexible seal on it that comes in direct contact with the cylinder, providing a physical barrier. These types of dispensers have a relatively high amount of friction between the piston and cylinder, which requires two-handed operation or some other method to stabilize the instrument during use. Because of this friction, the seal will eventually wear out and cause leakage. However, depending on the materials of construction, it may have a slightly wider range of application than any one model of floating piston dispenser. Let's take a closer look at the wiping seal dispenser and the implications of the design. As noted, friction from the wiping seal design results in increased operating forces that require two-handed operation. Alternatively, the bottle or the dispenser may be stabilized, such as with a bottle stand, or in some cases a spring-loaded piston could be employed, which may not be ideal in all circumstances. This additional friction and resulting seal wear means the dispenser will have a finite lifespan. One big advantage of the wiping seal dispenser, though, is that the liquid is completely contained within the instrument from the time it leaves the bottle to the time that it exits the discharge tube. This means when applied to a dispenser made with highly inert materials, such as fluoropolymers, it can be used for high purity chemicals for trace analysis with minimal degradation of the quality. The second design, the floating piston design, sometimes also referred to as a swimming piston dispenser, has no seal on the piston. Rather, a close tolerance gap of a few microns is between the piston and cylinder. This gap gets filled by the dispensed liquid, which acts as a seal. It also acts as a lubricant, allowing smooth one-handed operation. This also means that there is no wear between the piston and cylinder, provided the instrument is kept clean. While this design offers distinct advantages, selection of a dispenser with the proper materials of construction for the dispensed liquid is necessary to ensure the gap between piston and cylinder is maintained within tolerances for proper operation. Note that because there's not an active seal, the piston should be moved slowly and smoothly to avoid liquid sloshing above the cylinder wall, which is something you should also do with a wiping seal dispenser to maintain dispensing accuracy. Now let's take a look at the choice of materials of construction for a premium dispenser, such as the Dispenser. Borosilicate glass is a popular choice for the cylinder of a laboratory dispenser. A look around any chemistry laboratory shows that it's resistant to many common chemicals. For the cylinder, it also has the advantage of being transparent, so the user can visually verify whether it's been properly purged of bubbles for smooth, accurate dispensing. Pistons can also be made of borosilicate glass for a floating piston dispenser. It's as resistant as a glass cylinder. However, a glass piston paired with a glass cylinder is a poor choice for bases, as they can form a gel on the surface of the glass that will reduce the size of the gap on the floating piston dispenser, possibly even gluing them together. Coating a piston in PFA fluoropolymer is another option. PFA is a highly chemically resistant material and makes for a smooth surface that won't be affected by the bases that we mentioned earlier, but may not be the best choice for some organic solvents, as they can cause the PFA to swell, again disrupting that floating piston gap. Piston seals and wiping seal dispensers are also typically made of PFA fluoropolymer. The valve springs used in the one-way valves are another consideration. The valve springs are usually manufactured from either a platinum iridium alloy or tantalum. Platinum iridium alloy is an excellent choice for a valve spring due to its excellent chemical compatibility. However, it is incompatible with peroxides, catalyzing their destruction. For peroxides, a tantalum spring is a better choice, and it has good resistance to acids, but not bases. Regardless of whether a Bottletop dispenser is a wiping seal or floating piston design, materials used for other components of the dispenser are also crucial to the operation of the instrument. Ball valves are most often considered of the same borosilicate glass as the cylinder and having the same resistance. Borosilicate valves are suitable for chemicals with a density of up to 2.2 grams per cubic centimeter, which is the most majority of most laboratory liquids. For instances where borosilicate is not appropriate, such as high purity chemicals, hydrofluoric acid, which dissolves borosilicate glass, or bromine, which is too dense and would cause a filling valve to float, synthetic sapphire, a form of alumina oxide, is used. It can handle densities of up to 3.8 grams per cubic centimeter. Valve seats are made of alumina oxide ceramic, which is hard, smooth, and chemically resistant. And other structural components of this fluid path of the dispenser, such as the valve block and valve bodies, are made of ETFE fluoropolymer due to its chemical resistance, inertness, and ability to be formed into these types of structures. In addition, tubing within the unit, such as the filling, discharge, and recirculation tubes, are made from FEP or PTFE. Again, fluoropolymers well suited for extrusion and having high chemical resistance. For the outer housing, polypropylene is an excellent choice. It has very good chemical resistance, even though it's not directly in the fluid path, and is able to be molded into a variety of shapes. Braun's 4-model portfolio of Dispenser S Bottletop dispensers covers the vast majority of laboratory liquids. Dispenser S is suitable for most dispensing needs with a floating PFA-coated piston and platinum iridium valve spring. It's great for bases, buffers, other salt solutions, and many solvents and acids. The Dispenser S Organic substitutes a borosilicate glass piston for the PFA-coated version, and a tantalum valve spring, making it suitable for organic solvents, concentrated acids, but unsuitable for bases. The Dispenser S Trace Analysis is a wiping seal dispenser. It has a piston and cylinder of PFA with a wiping seal design and components made of inert materials. It is the dispenser used for ultra-pure chemicals. The Dispenser S Trace Analysis is available in 2 different models, one with a tantalum valve spring, one with a platinum iridium valve spring, to allow for a wider range of chemical compatibility. The Dispenser S Trace Analysis with platinum iridium valve spring is also suitable for hydrofluoric acid. In addition to basic function, a number of safety features are highly desirable due to the aggressive nature of many laboratory chemicals. One very important safety feature is to have a method of control to keep the dispenser from accidentally dispensing if the discharge tube is not properly attached or absent, so that directional accuracy of the dispensed liquid is maintained, keeping it from dispensing in unintended directions. A cap on the end of the discharge tube is also desirable, as a backstop from accidental dispensing, or helping to prevent drips if the instrument is moved. It should be secure when attached, yet easily removed when preparing for dispensing. A reinforced discharge tube is also highly desirable, immobilizing the tip of the discharge tube from flinging droplets of reagent if the tube is accidentally bumped. The cylinder of the dispenser should be enclosed in a sleeve to protect the end user from volumes of liquid and broken glass if the dispenser is knocked over. More than just the outer housing, but an overwrap of the cylinder if the dispenser is knocked over when the piston is raised. Ideally, this sleeve should also be transparent or highly translucent, so the user can confirm the purging of the bubbles before use. There are a number of other safety features to consider. A rotating valve lock is an important feature. It allows the bottle label to always be visible while dispensing, confirming the correct chemical is going into your receptacle. Thread adapters, often thought of as accessories, are an important safety feature, as having a full complement of them available allows direct dispensing from any reagent bottle, eliminating poured transfer from a stock bottle into a separate dispenser bottle. Most thread adapters are polypropylene, which is not resistant to all chemicals So the more common sizes should also be available in fluoropolymer such as PTFE or ETFE. Lastly, a priming or recirculation valve allows the purging of bubbles prior to dispensing by channeling the liquid back into the bottle. In addition to reducing the chance of splashing during dispensing, it also helps ensure the correct volume of liquid is dispensed. Keeping the instrument in priming mode after dispensing also reduces the risk of accidental dispensing.
Great information so far, Akbar. It's time for another poll. So you should see the poll question again, maybe on the right side of your screen. The question is, do you, if you have a bottle top dispenser in your lab, do you A, attach the dispenser directly to the reagent bottle, or B, pour the reagent into a special dispenser bottle? So I'll give everyone just a little bit of time to think about your response. So give it a few more seconds while waiting for some of you to finish selecting your answer. And that looks like it looks like we're good here. So I'm going to go ahead and close the poll. And share the results with you. So it looks like the majority of you do attach the bottle top dispenser to directly to the reagent bottle. So that's good information for us to have. And now I'll go ahead and turn it back to you, Akbar.
Yeah, that's great to know. It's good to know that people are attaching the bottle or the dispenser directly to the bottle. It's a much safer way of operation. Additionally, desirable features for the instrument to increase your convenience. There are a number of features you can use. An easy to operate volume adjustment mechanism, whether analog or digital. For the analog model, this is accomplished with a sliding pointer. That pointer should be easy to move to the desired volume and be well secured to avoid drift during use. If volumes are changed frequently, a digital display, such as on our digital dispenser models, provide highly reproducible settings without compromising chemical resistance. Calibration adjustment. ISO 8655 requires that liquid handling instruments be able to be fine-tuned for adjustment after calibration, with a flag to indicate when the instrument has been changed from the factory calibration settings. Cleaning. Is the instrument easy to disassemble for cleaning? This would include things like being able to remove the valves for cleaning, and are those valves enclosed so as not to lose the ball valves during the process. Also, can cleaning be performed without affecting the calibration of the instrument? It would be pretty tedious to need to calibrate after every cleaning. Other desirable features include an adjustable or telescoping filling tube. Is a nice feature. It allows the adjustment of the tube to the correct height of your bottle without cutting the tube, allowing for easier changes between reagents or if the packaging for your reagent changes. For the biologists out there, autoclavability may not just be a convenience, it might be a necessity. If you need to autoclave your dispenser, it should be able to withstand repeated autoclaving. A reminder that autoclaving is not a substitute for cleaning, and in fact can bake on residues that should have been removed prior to autoclaving. Lastly, are replacement parts and accessories easily available? If a part is broken or your application requires additional accessories, can you easily find and obtain these items? These would be things like replacement valves, filling or discharge tubes, thread adapters, etc. What accessories might you want to consider using with your Bottletop dispenser? Flexible discharge tube is a very handy accessory, especially for people filling racks of tubes or vials, such as inhalation fluid. The length of tubing made of PTFE, so it's as chemically resistant as a dispenser. Coiled to keep it neat, and with a textured weighted safety handle to keep it safe and secure for dispensing. Another accessory is the remote dispensing system, which allows dispensing from a chemical drum or other unpressurized container up to 30 feet away. This allows storage of chemicals from a secured location other than the bench top. A drying tube can be used to protect the contents of the bottle by sealing the dispenser to the bottle and forcing displacement air through a tube where drying agent, molecular sieve, or other agents can be placed. This can protect the bottle contents from atmospheric water vapor or other things, depending on the agent used. Similarly, a microfilter connector can force displacement air through a 0.2 micron filter to keep bacteria out of sterile media. Of course, there are instances when dispensed liquids are fairly innocuous, budgets are limited, and where the choice of a top-of-the-line dispenser is not always warranted. For these instances, Brand offers two dispensers to fit the bill, the Cerepetter and Cerepetter Pro. These dispensers feature a wiping seal piston cylinder cartridge made of polypropylene and high-density polyethylene, which can be easily replaced to renew the dispenser. Dispenser is spring-loaded to allow one-handed operation with the wiping seal design. Basic design, the Cerepetter, has EPDM elastomer valves and is designed to handle the needs of a typical biology laboratory. It's suitable for bases, buffers, dilute acids, and some polar organics. A nice advantage of the Cerepetter is that it can be used with sodium azide, a biological preservative that damages many higher-end instruments. The Cerepetter Pro replaces the valves and other components from the regular Cerepetter with more highly resistant materials, allowing a broader range of organics and acids than the basic model. It also has an amber cylinder sleeve to help protect light-sensitive reagents.
Wow, it sounds like there's a lot of really great options out there. It's now time for our final poll. Again, you should see this on the right side of your screen. The question is that we'd like to know is, how do you currently select or choose a Bottletop dispenser? Do you A, use what worked for you before, B, guess, C, do a quick internet search, or D, contact a sales representative or a selection chart or a manufacturer? So again, looks like there's a lot of you responding out there. So I'll just give you a few more seconds to finish up with your selection before I go ahead and close the poll. And we'll give it 5, 4, 3, and I'll close it. And let's see what we get. Great, it looks like a lot of you out there managed to contact a sales rep or a selection chart or a manufacturer, so that's great. There are some of you out there that guess, but yeah, Akbar, I think, is going to be talking to you next about how Bottletop dispenser considerations. So back to you, Akbar.
Thanks, Stephanie. That's actually a very interesting poll result. I want to mention that while using selection charts are good, you should make sure that the selection charts actually come from the manufacturer. I've done some internet searching and such, and have found that there's a lot of erroneous information out there, so you should really consult with the manufacturer directly or one of their sales reps to make sure that you're selecting the correct one. And then back to our presentation. To make the final decision on which Bottletop dispenser to purchase, there are a number of considerations that will determine which dispenser to select, or even if a dispenser is suitable. There are key questions to ask. What liquid or liquid type is being dispensed? What type of vessel is the liquid being dispensed from? And what is the volume range that you will be dispensing? So important to know what liquids are going to be dispensed when choosing a dispenser. bottle top dispenser for liquid needs to have a fluid path that is resistant to the chemicals dispensed, but the dispenser is also only suitable if it doesn't damage or degrade the quality of the chemicals dispensed. An important example is when dispensing high purity reagents for trace analysis work. That purity needs to be preserved throughout the dispensing process. Additionally, some liquids are not suitable for bottle top dispenser technology, so the properties of the liquid are important. Explosive liquid types, such as carbon disulfide, would not be suitable for bottle top dispensers. Another example would be suspensions, as the particles can cause issues with the mechanism, such as obstructing proper valve operation or operating a floating piston or piston seal. The next consideration is, what am I dispensing from? A better dispenser will allow you to mount directly to the bottle you purchase your reagents in, eliminating port transfer. Reagent bottles come in a variety of volume sizes with different bottle top threads, so a variety of chemically resistant thread adapters should be available. Some dispensers also allow you to dispense from chemical drums, but pressurized vessels are not suitable. Due to the orientation of the valves, mounting a bottle top dispenser to a pressurized container will cause the container to empty of its own accord. You also need to consider the volume of liquid you need to dispense. Bottle top dispensers can comfortably dispense volumes from 100 microliters up to 100 milliliters, though not from the same instrument. Volumes outside of those ranges are best handled with other technologies. In most cases, an adjustable volume dispenser is the type of choice, but for some applications, a fixed volume model is appropriate. For reasons outside the scope of this presentation, dispensers should be operated in the upper half of their volume range for the best accuracy. After deciding on the features you need for your next bottle top dispenser and answering the key questions for selecting a bottle top dispenser, choosing the specific model can still be a bit daunting. Fortunately, Brand has selection charts with clear yes/no answers for many common laboratory chemicals. If your chemical is not on the list, reach out to BrandTech customer service or technical support via the telephone, web chat, or email, or contact your local BrandTech sales representatives. We're here to help. And just as a reminder, this webinar is being recorded and will be made available at a later date. I thought that I would also mention that we are launching a buy two, get one free promotion for Dispenset S bottle top dispensers that will start on November 1st. You can find this information on our website at www.brandtech/promotions, and it will be sent to you in a follow-up email as well. Again, that's www.brandtech.com/promotions. And we'll now move to Q&A to see what questions have come in.
Great, Akbar. I think that was a very informative presentation. I really think that our attendees today got a lot out of that. And also, that's a pretty sweet promotion that we have going on right now. So everyone should make sure to take advantage of that. And again, before we get started with Q&A, I do want to remind you that there's going to be a post-event survey that's going to pop up after you exit the webinar. And again, we would really love your feedback. So we've had a decent amount of questions come through, but the first one is, how can I dispense from a 20-liter carboy?
That's an excellent question. Your typical carboy has a pretty large cap on it. I believe it's an 83 millimeter threaded cap, and that's larger than our largest thread adapter that's available for the instrument. The easiest way that a number of people have done is if you get a hole saw, which is a specialized kind of drill bit, you can drill a 1 3/4 inch hole into the top of a replacement carboy cap. And then you can take one of our standard thread adapters, push it in from the underside so that the threads protrude on the top, and then you can attach the dispenser to those protruding threads. If you send a note over to the folks either through the web chat or an email or something, we can certainly send you some instructions on how to do that.
Okay, perfect. Here's another one that came in through Q&A. How often should the dispenser be cleaned for sulfuric and nitric acid as well as sodium hydroxide?
Well, sulfuric acid or nitric acid, I'm going to have those be two separate issues as opposed to a combination of the two. Those are generally pretty clean chemicals out of the bottle. As long as the instrument is operating smoothly, it shouldn't need to be cleaned all that regularly. Or if you, as soon as it starts feeling gritty, or the liquid doesn't seem to be dispensing smoothly, you should take the instrument apart, completely disassemble it, and clean it. Sodium hydroxide, being a salt, it will, especially if it's more concentrated, it will tend to form crystals, and you'll want to clean that more frequently than if it was one of the acids. But again, if it starts feeling gritty, especially with something like sodium hydroxide, if you're operating the dispenser faster than appropriate, sometimes some of that sodium hydroxide will splash over the top, and you'll get crystals on the top of the cylinder. And when you take it apart to clean it, you'll want to take a spatula or something and scratch off those crystals that are at the top of the cylinder.
Okay, great. Another question has come in. For what chemicals would a drying tube be beneficial?
Drying tube. Drying tube's a handy feature. Particularly popular application for that would be if you're dispensing environmentally friendly scintillation fluids like EcoScint or Optifluor. Those liquids much more friendlier than the old scintillation fluids, but they tend to precipitate when they get water in them. So if you're like in a humid environment and you're using these scintillation fluids, those liquids will precipitate out, and those will typically fall to the bottom of the bottle, and you can actually aspirate those up into the dispenser, which is not good for the dispenser, but it also kind of inactivates the scintillation fluid. So if you mount a drying tube to that and you put some Dry-Rite in there, that will absorb out the atmospheric moisture and keep those precipitates from forming. I thought I'd actually add to that. It's a good idea not to have the filling tube flush to the bottom of the instrument, of the bottom of the bottle, but having it raised up just slightly so that if things do precipitate out, some sort of crystals or whatever, that they won't be immediately drawn into the instrument. So that will help prolong the life of your instrument.
Okay, and a sort of a little bit of a follow-up question that has also come in through Q&A. What is the proper preventive maintenance to ensure extended life on the dispenser?
Really, the big thing is keeping it clean, especially with a floating piston dispenser, but also with a wiping seal. If they feel gritty at all, if you notice changes in the operation, the best thing you can do is stop using it, take the time, clean it up, pull the piston out of the cylinder and wash them independently. If the instrument has removable valves, you should take those out. You can put those into an ultrasonic bath, or use an appropriate cleaner. If it's an aqueous solution, you can use like a detergent. But if you're dispensing some sort of organic solvents, you'll want to use another organic solvent to make sure that you remove any sort of residues from that. I mean, really keeping it clean and operating it slowly and smoothly are the best ways to ensure extended life of your instrument. Oh, and also use a dispenser that is appropriate for the chemicals that you use.
Yeah, that's probably pretty important.
Yeah.
Making sure to use a compatible chemical. All right, we
Right.
have a few more questions that have come in through Q&A. Do you sell 2-liter reservoir bottles? I never see them in catalogs.
We have our largest standard threaded bottle is glass bottle is a 1 liter, but we do have some larger bottles. They're typically used for burettes, but they're a shorter glass bottle, so it's got a lower center of gravity. Let me see if I can find these here. They're 2 liters. We have them in clear and amber as well, and they have a standard taper joint, so you can rather than threading the bottle or the dispenser to the bottle, you can get one of our standard taper joint adapters and just pop it right on there.
Okay, great. So another question, what is the maximum volume that the Seripetter holds and or dispenses?
For our Seripetter line, the largest one is a 2.5 to 25 milliliter size. If it gets larger, then you need to have a stronger spring, and it becomes more unwieldy to operate with that sort of design. So we stopped at 25 milliliters for that size.
Okay, great. Looks like we have one final question here. How easy is it to calibrate if needed? Is it something that people can do in the lab?
Calibration of a Bottletop dispenser is actually easier than a pipette because you don't need to have the same high resolution balance that you might need for a pipette. I believe for most sizes of pipette, you'll want or a dispenser, you'll want a 4-place balance. I have to look at that. We have SOPs actually on our website to do that. But essentially, you dispense distilled water at the nominal capacity, 50% and 10%, and you do your statistical analysis to make the calibration adjustments with the dispensers. We have for the analog versions, there's a set screw on top that you can turn it. Every turn adjusts it by some number of microliters. And for the digital models, we have we call our easy calibration mechanism, which allows you to change the display to the actual dispensed volume. So it reduces the trial and error needed to calibrate traditional type designs.
Okay, and there's one final question about part numbers. And I don't know if you still have it handy, but do you happen to know the part number for the amber 2-liter bottle? If not, we can reach back out to this person.
Sure, actually, I do have it right here. This is a borosilicate glass bottle, so you'll want to make sure that that's the same kind of. So it's catalog number 23320.
Okay, great. Okay, great. I think that's all the questions that we had come in. So, and they were all really, really great questions. So thank you so much. If you think of something that wasn't answered during this, please feel free to email us again at support@brandtech.com. And I would like to thank all of you for your participation and attention today.
Yeah,
Have
thank
a great
you.
afternoon.
Okay.